Hello, my name is Gemariah Valencia and this is my Lab 3 video lab report of constant velocity motion. My observation is of a green EXPO marker rolling on a table, and by using physics concepts, the computer model produced similar results with the tracker. The model can then provide close predictions about the object's positions based on the momentum principle. Note that I use centimeters per second, and this is because my marker did not travel a significant distance, meaning that if I converted this into meters per second, it would seem like my marker did not move at all. This is my video, and I oriented the axis so that the way the marker is rolling would be in the positive x direction. I also calibrated the stick to 2.2 centimeters, and that is the diameter of my marker. The average position is then tracked by the center of the marker cap. And as my marker rolls, my graphs a positive slope, and that's because of the positive x-axis. My initial position, though I tried to make it as close to the origin as possible, was a little bit off by 0.027. So my initial position for this calculation is negative 0.027, and my final position is 44.65, and that is after 2 seconds. So using these information, I was able to calculate a velocity of 22.34 centimeters per second. I then used this velocity and the initial position and put those into Python, so that this is my velocity right here, and this is my initial position of my ball. My force net vector is 0 because the marker is in constant velocity when I was observing it, and therefore there were no additional forces acting upon it. As you can see, the ball is moving in a positive x direction, and my graph is graphing a positive linear slope, meaning that the velocity is constant. I then use this information given by the Python test and the tracker information, and I put them into an Excel spreadsheet. The scatter plot plotted the positions of the marker, which is the dotted blue line, and I then put a trend line, which gave me an equation of 22.596x plus 3.0539, and getting the derivative of this would give me the velocity of this trend line, and it is 22.596. Compared with the velocity that I calculated, that's much greater. That's a little bit greater. And this orange line right here is the information that Python gave me, and that is a 22.34 slope, which is my velocity that I inputted earlier. And so the dotted gray line represent the position of my marker. And in conclusion, I said that ideally the force would equals to 0 because it is in constant velocity. However, since my tracker say that my velocity is 22.596, it was not the same as the model's prediction. However, it is very close, and so this is the ideal. Some questions: what if you have a different origin? My answer is that if given the same amount of time and in constant velocity, my marker would travel the same distance, though end up in a different position. For example, if I started in a more negative position, I would end up in a location less than 44.65. What does it mean? How many pushes and pulls are added together to give 0 net force? I said that I don't know how to tell the amount of push and pull, but I do know that they are equal, and because of this, they cancel each other out and give the net force of 0. And the momentum principle applies to that.